Today we're going to learn something new. We are going to factor trinomials by using substitution. So please be patient with this. It's like I mentioned to you guys before, it is confusing. So if you don't get it right away, we'll just keep redoing it until you get it. All right. The first thing I want you to look at is this is 3x squared minus 2x minus 8. When we're looking at the 3x squared, what we want it to be is a perfect square. And by perfect square, what I mean is if you look at the x squared, we can take the square root of it and get x, because x times x is x squared. When we look at the 3, we can't do that, but we want to get the 3 to be multiply it by another number, which is going to be 3, so that it becomes a perfect square, which would be 9, because 3 times 3 is 9. And then what happens is we can take the square root of 9, and it will be 3. So what the first thing you're looking at, we're going to multiply this whole equation by a number. And we are going to multiply it by 3. And the reason we're going to multiply it by 3 is because this 3 times 3 becomes 9. So it looks something like this. 3 times 3 times x squared minus, we're not going to actually multiply it all, we're distributing the 3 through the whole equation, but we're not going to actually do 3 times 2. We're going to keep it 3 times 2x. Okay? And then minus 3 times 8. And you'll see why we're doing that in just a minute. The next thing, so then what we have here is we actually have 3 squared. So we can say, okay, we have 3x squared minus, and we have 3 times 2 times x. So what we're going to do is we're going to call this 2 times 3x in parentheses minus, and we don't care about the 3 times 8. We're just going to write it as 24. And this is where the substitution comes in. See this 3x here and this 3x over here? We're going to substitute that 3x in. So we're going to say we're going to pick a different variable. I'm going to pick p because that's what your book has been doing. Let p equal 3x. So I'm substituting in, instead of 3x, I'm going to write p. So I write p squared minus 2 times p minus 24. That's where the substitution comes in. And what we've done is now we have it here so that there's a 1 in front of this variable. Because when we first started doing this, all of our trinomials they had a number 1 in front of it, and it was a lot easier to factor. So next we're going to factor from here. All right, so we're going back to when we first started factoring. We are looking for factors of 24 or negative 24. And when those factors are added together, they're going to equal negative 2. And again, we would start with 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And what happens here, if 4 is positive and 6 is negative, I'm going to end up with 4 times negative 6 is negative 24, and 4 plus a negative 6 is negative 2. And that's what I'm looking for right here in the middle. When I rewrite this then as factoring, it's going to be p plus 4 times p minus 6. And that's how we factored it. Okay? We're not done yet because we have to now resubstitute back in what was p. Remember, p was equal to 3x. So I'm going to substitute back in because p equals 3x. I'm going to put 3x in for p. So I have 3x plus 4 times 3x minus 6. We're still not completely done because we need to factor out a 3 here, the greatest common factor. So this one is left the same, 3x plus 4 times 3 times x minus 2. And all I did here was factor out a 3. The last final step we have to do is in the very beginning, when we multiplied that equation by 3, we now have to divide by 3. And when we divide by 3, this 3 right here goes in the middle. So we would have 3x plus 4 times x minus 2. And that's how you do it, and that would be the factored way. Now, I know you're like asking yourself or saying, that's a lot of work. It is a lot of work. And this is where you make a choice. When I've told you before, there's more than one way to do something, and you can always do the grouping. I think the grouping is less work than this, but that's just my opinion. You might like this way. So either way is okay to do it, but I'm asking you to learn this way so that you can at least try it, and maybe you'll like it. Maybe you'll choose to do it a different way, and that's okay. The choice is yours. But it's always good to be introduced to more than one way to do something. And, oh, that's what it is. I am going to go ahead and we will try another one. The next one I want to try, and I want to make sure I write it down correctly, is 2x squared minus x minus 6. Okay, so remember, I am going to multiply the whole equation by a number. In this case, I'm multiplying by 2. And the reason I'm multiplying this by 2 is I need this to be a perfect square. And 2 times 2 is 4. So basically, whatever this first number is, that's what you're multiplying by. Okay, so I have 2. I'm going to go ahead and write it out like this so that you can see it. Minus 2 times x minus, and the last one you're going to go ahead and do the 2 times negative 6, which is minus 12. And all we've done now is a distributive property, multiplying that 2 all the way through. What I really have here is 2x squared minus 2x. And before we had a number, keep in mind this is 1 time. There's a 1 here in front of this x. We just don't have to write. Minus 12. You can see what we're going to substitute this time. We're going to substitute the 2x. Over on the side here, I'm going to write p is equal to 2x. And then instead of 2x, I'm substituting in p. P squared minus p minus 12. And now when I factor this, I'm looking for factors of negative 12 that when they're added together would be negative 1. And I'm getting better at this now, so I'm not going to write every factor, but I could do 1 and 12, 2 and 6. But I know when I get to 3 and 4, 3, I'm trying to write a negative sign and it won't go. 3 times negative 4 is negative 12, and 3 plus negative 4 is negative 1, and that's what I wanted. So this is going to factor into p plus 3 times the quantity p minus 4. I'm still not done. I feel like I should be, but I'm not. I'm going to have to go back and substitute this 2x into p. So I have 2x plus 3 times 2x minus 4. This one is fine, the 2x plus 3, but this I have to factor out a 2. So I have 2 times x minus 2. I'm running out of room here. And remember in the very beginning, I multiplied by 2 right up here. So now I'm going to divide by 2, and that just gets rid of this 2. So my final answer for this would be 2x plus 3 with parentheses times the quantity x minus 2. And that's the factored form of that. again, being the conscientious student that you are, you could go ahead and multiply that and check your answer to make sure that you would get what you started out with. I think I have time for one more example. All right, this equation is 10x squared plus 3x minus 1. I'm going to multiply the entire equation by 10. So I end up with 10x, and the whole thing is squared. And then I have 3x times 10, and I'm going to write it this way, 3 times 10x, because with multiplication it doesn't matter what order it's in, and then 10 times negative 1, which is negative 10. I am substituting in, so this time I'm going to let p equal 10x. This is a substitution. I'm substituting in p wherever I see a 10x in this equation. Instead of, in place of this 10x, I write p, and it's p squared plus 3 times p minus 10. And then from here, I factor. I'm looking for factors of 10, negative 10 that equal 3. So that negative 10 would be 2 and 5, and the 5 is going to be negative. Or positive, sorry, because I want the 3 to be positive. I have p minus 2 times the quantity p plus 5. I'm ready to substitute 10x back in for p. So in place of p now, I am putting 10x minus 2. And I am putting in for p 10x, and then plus 5. So all that is substituting the p for the 10x. I am now going to factor both. This time I can factor something from both equations, and this side I can factor out a 2. So I have 5x minus 1. And over here, I can factor out a 5, and I will have 2x plus 1, right? And now I look back, what did I do in the very beginning? I multiplied by 10, which means I have to divide the whole thing by 10, and that's where this 2 and the 5, because 2 times 5 is 10. So I'm dividing by 10 and dividing by 10, which leaves me 5x minus 1 times 2x plus 1. And that's how you do substitution. This explanation I took right from the book on page 297. If you want to look at the book and see how they did it. We basically did it the same way. They're just using ax squared plus bx plus c and using, I think sometimes it's confusing to me how it's worded, but that's what they're doing in standard notation if you're trying to follow it in the book. Again, that was page 297 in your textbook if you want to follow along. Just to show you how this works, if I quickly, I think I have like a minute and a half left. If I want to check my answer, I'll do 5x times 2x, which is 10x squared. The last would be plus 5x minus 2x minus 1, which gives me 10x squared plus 3x, this is a plus, minus 1. And that's exactly what I started out with, so we did it correctly. All right, I'm going to post some homework, and then if you have any questions, I can go over that with you if necessary.